Okay, we're going to do the MEI M1 paper, Summer 2007. My voice isn't very well, so we'll see how long we last doing this. Okay, firstly, question 1. We've got this diagram here with 40 going off this way, 120 this way, Q this way, and P this way, and an angle of 60 degrees here. So I'd split this into horizontal and vertical, so this is P cos 60, this is P sine 60, that one's cos, that's cosy to the angle. Therefore, resolving horizontally, we know that it's in equilibrium, so that we know that 40, we can keep doing it in, has got to equal P cos 60. Usually I might do F equals MA, so 40 minus P cos 60 equals 0, amounts to the same thing. So P is 40 over cos 60. Which we can work out. So that equals 80. And then, so that's considering horizontally. So if we then consider vertically, I'll do this the other one, I'll do F equals MA on this one, so it kind of, you can see the other way of doing it. We'll go back to black. So if we say up is positive 120 minus P sine 60 minus Q equals 0. So Q is 120 minus 80 sine 60, just rearranging that. And that's 120 minus 80 60, which is 50.7 newtons. We'll probably ought to put some newtons on that one too. There we go. So that's part 1 and part 2. Question 2. A car passes a point A, travelling at 10 meters per second. Its motion over the next 45 seconds is modelled as follows. The car speed increases uniformly from 10 meters seconds to 30 meters per second. That's T equals 10. And then increases uniformly to 40 meters over the next 15 seconds, so T is 25. It's still going 40 meters per second. Then it maintains the speed for a further 20 seconds, so then it's going T equals 45, and it's still going at 40 meters per second. It just helps me picture what's going on. Sketch this graph, a speed time graph to represent this. Okay, so it starts at 10. Okay, and then it maintains that through to 45 seconds. Calculate the distance from A to B. So this is speed, this is time. So the area underneath is the distance. So this is part 1. Part 2 is the area, is the distance. Oh, how should we do this? Let's do this as a couple of trapeziums. It's probably the easiest. So it's a half, 10 plus 30 times 10, plus a half, 30 plus 40 times 15, plus a rectangle, 40 is 20, equals 400 times 40 times 10 is 400 times 200 plus 35 15 525 plus 800 is 1525 meters, because they're all, the speed is meters per second, and that's just seconds. Okay. When it reaches point B, the car is brought uniformly to rest in t seconds. The total distance is now 17 meters. Okay, so let's just draw this new bit in red. So that's t seconds is now 1700 meters. So 1700 minus 525 is 175 meters. So we can do this as triangle, it's probably my preference, or we can use Suvat, but half the base times the height has got to equal 175. So we've got 20, so t is 175 divided by 20 is 8.75 seconds. Okay. So, question 3. So we've got this little scenario here, the floor, this is 15 kg, this is 20 kg, this is a light rod. Let's assume that it's in tension, so we're going to assume the rod is pulling down that weight, and this is in tension as well, so we're going to call that T1, this is T1, T2, T2. Okay, so part 1, 20G here and a 20G here. There we go. Why is the tension the same throughout the string? Well, it says passed over a smooth pulley, and the string is light. Obviously, if the string had mass, that would affect it, and if the pulley wasn't smooth, so it's got a smooth pulley and a light string. Okay, to calculate the force in the rod. Okay, so we're going to do F equals MA on the first one. We know it's in equilibrium, so force is down on the first one, 15G minus T1 equals 0. So T1 is 15G, because it's not accelerating. And then on T2, on the 20 kg, we've got, let's keep the directions the same, consistent with the diagram. So we've called this positive. So we'll say T1 minus 20G minus T2 equals 0. So we've got 15G minus 20G minus T2 equals 0. So T2 equals minus 5G. Therefore, we know that our diagram must be wrong. Therefore, we've assumed its intention. So it is 5G in thrust or compression. Okay. Question 4. Okay, we've got a standard truck question here. Got 500 newtons here. 10,000 kg. Don't think we're going to need this, but there we go. G just reiterates the units. It's got a rod between them, so we're going to call that T, assuming it's in tension. We've got P pulling that. And we've got 300 pulling this. And so this one's 10,000, so this is 10,000 G as well. It's now accelerating, so we do need to use F equals MA. Okay, to calculate the value of P. Okay, so we'll do the whole system. F equals MA on the whole. So we've got P forwards minus 500 minus 300 equals the whole mass times the acceleration of the whole. So P equals okay, truck A, so that's part 1, part 2. Truck A is now subjected to an extra resistive force of 2,000 newtons. So this is A, so there's another force come in here of 2,000. Maybe the brakes are faulty, sometimes they say that. P doesn't change, calculate the new acceleration. we're going to keep the same positive direction. So we've got 4800 minus 2800 equals the mass, which hasn't changed, times A. So A is less, hopefully, otherwise we've done something wrong. Is 0.1 meters per second squared. Calculate the force in the coupling between the trucks. So in this case we can now do, which will we do it on? Doesn't really matter. F equals ma on a single truck, because we want to get this T involved, so we can do it on A, which is this truck here. So forward we've got the T, backwards we've got 2500 equals the mass of the single truck times the acceleration of the single truck. So T equals 3500 newtons. Okay, it doesn't ask us, but that's in tension. Okay, so block of weight 100 newtons, weight 100 newtons. That's 100 newtons there. Is at 35 degrees to the horizontal. And there's 40 newtons here. Block is in equilibrium. To calculate the frictional force is on a rough plane inclined at 35. The block is in equilibrium with a horizontal force acting on it. Calculate the frictional force on the block. Well, it must be on the point of sliding. So there must be something to counteract this force here. So it must be on the point of sliding up. Therefore the friction can be down, otherwise there's nothing opposing the 40 newtons and it would go up. Oh no, maybe not, because there's reaction force here. Oh, don't know. Well, let's try it in this direction and see what the maths brings out. The maths might tell us that I get a negative friction. So that's the 35-degree angle. This is 100 cos 35. This is 100 sine 35. And this one kind of see the Z angles in there. That's your 35 degrees there. So this is 40 cos 35 is in this direction. This is 40 sine 35 in this direction. So we've got R it's in equilibrium, so up equals the 2 down, which is 100 cos 35 and 40 35, but I'm actually not interested in that, so that was a waste of time. But that one we've got f plus 100 sine 35, that's down the slope, equals 40 cos 35. Okay, so f equals 40, 35 is minus 24.59. Therefore, friction is 20.6 newtons up the slope. Okay, question 6. A rock of mass 8 kilograms is acted upon by just two forces. So F is a vector equals M, a scalar, times A, a vector. The forces is minus 80k, and this one minus I plus 16j plus 72k. Equals 8a. A equals minus an eighth I plus 2j, and that's going to be minus 8, so that's minus k, which is what we've got. Excuse me. The rock passes through the origin, in vector O with velocity this. So U equals I minus 4j plus 3k. 4 seconds later, this point passes through the point A. So find the position of that. Got an acceleration, so S equals U t plus a half a t squared, and no S naught because it's originally through the origin. So U is I minus 4j plus 3k times t plus a half a, which is minus an eighth I plus 2j minus k times 4 squared equals 4i minus 16j plus 12k plus, well, we're going to times by 8, so this is minus I plus 16j minus 8k. So altogether we've got 3i, no j's, plus 4k. Find the distance, so that's part 2. Part 3, distance OA, so the length of that is the square root of 3 squared plus 4 squared equals 5 meters. find the angle that it makes with the horizontal. So it's got no got I, J, okay, so it's gone 3 out and 4 up, and then we want the angle with the horizontal, which is that one there. So we want tan of theta is 4/3, so theta equals down to -1, 4/3, which is 53.1 degrees. Okay, question 7 and into 6b. So, figure 7 is a sketch of a velocity time graph. Let's just sketch it out. Just helps me visualise what's going on. Oh, except it just starts at there. So we've got A. That's bad sketch. Let's start that again. So A is down here, origin is there, this is T, this is V, and we know that V is T squared minus 2T minus 8 for the interval -3 up to 5. Write down velocity of the insect when T is 0. When T equals 0, velocity is a vector is -8. Just by subbing in 0 into that. Show the insect is instantaneously at rest, so V equals 0. 0, 0 equals T squared minus 2T 8. T minus 4T plus 2, therefore T equals 4 minus 2. You could sub it in, but that's a slightly more direct way. Therefore, if you can see it, preferable to do it the direct way rather than summing it in. Determine the velocity of the insect when the acceleration is 0. So, acceleration equals dv by dt, which is 2t minus 2. When a equals 0, 0 equals 2t minus 2, t equals 1, and we want the velocity. So the velocity equals 1 squared minus 2 times 1 minus 8, which is 1 minus 2, which is minus 1, which is minus 9 meters per second. Write down the coordinates of the point A shown in figure 7. So A is 0, so the turning point. So A is the point 1 minus 9. Don't let that confuse you. 1 minus 9. Okay, easy to miss that last little part because the way it seems to be written in the question. Okay, so don't miss that one. Part 4. Calculate the distance travelled by the insect from t equals 1 to t equals 4. So the distance we're going to integrate from 1 up to 4 t squared because we want area 2t minus 8 dt, and from 1 up to 4 it's all going to be negative, so we're going to get a negative answer. We don't need to worry about two separate areas. That might come in the last part, but so we can get t cubed over 3 minus t squared minus 8 t 1 and 4. So we've got 4 cubed over 3 minus 16 minus 4 eighths of 32 minus a third minus 1 minus 8 equals 64 divided by 3 minus 16 minus 32 minus 18, so that's negative as we expected. So the distance travelled equals 18 metres. Interestingly, you don't get the mark if you write minus 18. Okay. Part 5. Write down the distance travelled by the insect in the time interval minus 2 to 4. Slightly weird. So let's just have a look back at our diagram. So we've done. So we've done. Okay. So we've done 1 to 4. They want minus 2 to 4. So we can be clever and we can see symmetry, or we can do the integration again. So let's be clever and say that that's the turning point. Quadratics are symmetrical, therefore actually our answer to this one is just going to be the distance is 2 times 18, which is 36 metres. But we could do the integration from minus 2 up to 4 of t squared minus 2t minus 8 dt, and we'd get the same thing. We'd get minus 36, therefore 36 metres. That's the distance. Okay. So then part 6, this is the bit where you've got to bear in mind your pure maths. How far does the insect walk in the time interval 1 to 5? Well, 1 to 5, well, we do 1 to 4, that's negative, but it walks that, and then we need to do 4 to 5, so we're going to integrate 4 to 5, so I'm just going to use the answer that we've got before. And I'm going to say that's 5 cubed over 3 minus 25 minus 40 minus 64 over 3 minus 16 minus 32. So this is 4 to 5 is 125 divided by 3 minus 40 is 10 over 3. So the distance travelled not the displacement, the distance travelled, well, does 18 plus 10 over 3. 10 over 3 is 3 1/3, so that's 21 1/3 metres. So that's all to do with the areas and needing to make them positive. So you can't just integrate between 1 and 5. The whole pure maths thing in there about finding the total shaded region is the same question. Okay, on to the final question, question number 8. So a ball is kicked from horizontal ground. There we go, there's a horizontal land. It leaves the ground at a speed of 25 metres a second. An angle of theta to the horizontal. And we know that cos, which is 0.96, and sine theta is 0.28. I'm sure those can't be exact, but we're going to use those. Okay. Maybe they can. We could check sine squared plus cos squared being 1, but I won't. Okay, show that the height y above the ground after projection is given by. So we want, so s, so y equals ut, which is 25 sine theta t minus g is 9.8, so half 9.8 t squared, and it's starting at the horizontal, so x, y, that's that, so x equals 25 cos theta t. We know what those values are, so let's do the x one first. 25 times 0.96 is 24 t. Y is 25 times is 7. T squared. Calculate the maximum height. So this is when the vertical velocity is 0. So if we do this by differentiation, it's so y dot equals 7 minus 9.8 t. You can do it by suvat to get the same equation when that's 0. So t is 7 over 9.8. T is 5/7. Do we want the time? What are we after? Calculate the maximum height, so we want the y value. So y equals 7 times 5 over 7 minus 4.9 5 over 7 squared equals 5 minus, it's going to come out nice, I think they've tried to do some nice numbers here. 4.9 times minus 5 over 2 equals 2.5 meters. There we go. 3. Calculate the times at which the ball is at half its maximum height. So when y equals 1.25. So 1.25 equals 7t minus 4.9t squared. So 0 equals, we'll take it all over the nicer side, which is making that positive. That's going to be negative, but that one's still positive. Equals minus b plus or minus the square root of b squared minus 4ac okay, 7 plus and the same thing with the minus in there. Naught point 209. There we go. And the distance travelled between. Sorry, where are we? The horizontal distance travelled between the balls in those times. So horizontally, it's constant speed, so it's actually reasonably straightforward. So the distance equals 24 times there are other ways of doing that, but I think that's probably the easiest. So 24.2 meters to 3 significant figures. Okay. Okay. So question 4. Determining the following when t equals 1.25. When t equals 1.25. So y dot equals B, whether the ball is rising or falling. That's A. Falling as y dot negative. C, the speed of the ball. The speed, well, it's travelling horizontally at 24, so it's 24 squared plus minus 2.5. 6 meters per second. And then the very last part, show that y equals that, hence or otherwise find the range of the ball. So we've got the equation, y equals 70 minus 4.9 t squared. We've also got x equals 24t, so we know that t is x over 24. Put that into the other one, we get y is 7x over 24 minus 4.9 x over 24 squared. And okay, so we're going to take 0. They want us to take, it's bizarre, but 0.7x times 24 squared. 0.7 x out, and we're going to take 24 squared out. That means we're left with, to get this one, we need a 24 on the top times 10. Then that gives us that one. And this one we've got a 49. Oh no. We're left with a 7, I think. Slightly bizarre. X. Let's just check that. 7 times 0.07 is 4.9. 24 squared on the bottom. Yeah. So that equals 0.7x over 576, 240 minus 7x. And I shouldn't really say this, but once you've written that line down, you could just write that one down. And it would be hard work to see that you didn't understand what you were doing, given that you substituted that in. They just want to see that you can see that 24 squared is 576. The range of the ball, so when y equals 0, 240 minus 7x must equal 0, so x equals 240 over 7. Which is 34.3 meters.